So here we have our two functions, and now we're going to get into those ones that we did at the beginning of yesterday where we looked at functions being inside square roots, in particular parabolas being inside square roots. So in our first example, g of f of x, well, if we're going to determine the explicit equation, f of x is the square root of x. And then g of x, whatever you put into g gets squared and then you minus 4. So it would be the square root of x squared minus 4. And if we simplify this, we're just going to get x minus 4. If we had to graph that, that's just a straight line. But we have to be a little bit careful. And the reason we have to be a little bit careful, we've determined the explicit equation, and this is one of the reasons they say then state the domain. When you look at your final answer, y equals x minus 4, what's the domain of that? XCR, everything, right? Everything is possible. But in these composite functions, we've got to check all the way along the way to make sure we didn't have any non-permissible values along the way. And if we look right at the beginning here, the very first thing that happens is x gets put into a square root. Could you put a negative 5 into that square root? No. We know that we can't take the square root of negative numbers. So even though in this step here, that square root goes away because it gets squared, we technically still can't have negative numbers inside that because that's how the function started. We can sort of imagine, you know, when we did our function machines, we can sort of imagine our two function machines like this. There's our green machine, and then it goes into our blue machine. And our green machine was the square root of x, and our blue machine was x squared minus 4. So you put in a 4, out would come a 2. You put the 2 into the blue machine, and out would come nothing. Oh, you're like waiting forever. Nothing comes out, but it's the right thing. If you put in 9, out would come 3. If you put 3 into your blue machine, square it minus 4, out would come 5. Can you see that this number here, 9 to 5 and 4 to 0, is following this rule, x minus 4. But if you started off with negative 1 in the green machine, it's going to explode. Okay, there's no sad face one, so I have to invent it. Yeah, it's going to be bad. So if you put anything negative into that first one, it's going to be bad because we have initially a square root of x. So our domain for this one would just be x is bigger than or equal to 0. And the graph of this function, if we were to graph it, well, we would graph x minus 4 like normal, which has a y-intercept of 4 and a slope of 1, but we would only have this part of the graph where x is bigger than 0. You wouldn't have anything less than this. So it's sort of like half of a line. Okay. The second one, f of g of x, well, g of x, there it is. There we go. G of x is x squared minus 4, so we would have f of x squared minus 4. Notice right now there's no restriction on the domain yet. X can be any number so far. And then whatever you put into f gets square rooted, so this will equal the square root of x squared minus 4. What does that look like? Well, the domain here, now we have that the inside x squared minus 4 has to be bigger than or equal to 0 because we can't take the square root of a negative number. So we have to figure this out. So in order to find the domain, we need to solve this inequality. How do we solve an inequality? We find out where it's equal to 0, and if we factor this as a difference of squares, we find out that it's equal to 0 at 2 and negative 2. And once we have those things, we can create our number line, put negative 2 and 2 on our number line. You can draw circles and fill them in because it could equal 0. And we need to make a true-false section for each of these. If you try something less than negative 2, like negative 4. Negative 4 squared is positive 16. 16 minus 4 is 12. 12 is bigger than or equal to 0. This section will be true. If you try something between negative 2 and 2, like 0, if you plug it in, 0 squared minus 4 is negative 4. That is not bigger than or equal to 0, so this section would be false. And finally, something bigger than 2, like 38.7. 38.7 squared minus 4. You don't really need to figure it out. Can you tell that that's going to be bigger than 0? So this section will be true as well. Again, another way that you could think of this is once you make this number line, you could think of this number line as your x-axis. And if I drew my y-axis here and I actually graphed y equals x squared minus 4, well, our transformations unit says that that's a parabola that's been moved 4 down. So if I move that parabola 4 down, there's my vertex. It goes through those x-intercepts because that's what we found when we set it equal to 0. And can you see from that green graph that the only time that parabola is bigger than 0, or when the y values are bigger than 0, is in this section and this section? So there's two ways you can sort of figure out your true, false, true table. One is by plugging in values to check them, and the other is by actually drawing the parabola and looking at it and finding where is it above 0 and where is it below 0. Now, the reason we get into this true, false, true is if you do take a calculus course, this same idea of true, false, true, or positive and negative comes up in that again. So this will be a concept that you see over and over again. Welcome back to class. Now, if we were asked to graph the square root of x squared minus 4, well, then we would use what we learned in chapter 2. So in chapter 2, if you wanted to graph y equals the square root of x squared minus 4, first you could graph the inside function, which we already did above, but we'll do it again. It has 2 and negative 2 as intercepts. Wow, perfect. There's our vertex. Nice. And if you had this function and you were going to graph now in green the square root, remember how we graph square roots. At 0, it's not going to change. Whenever the y value is 1, if we go straight across, these 2 points won't change. And between 0 and 1, your green graph is going to be slightly above, and after it's going to be below. Slightly above, and after it's going to be a below. So this is going to be the graph of our function. And as far as our true, false, true goes, that's going to tell us that our domain of our green graph is going to be x is less than or equal to negative 2, or x is bigger than or equal to 2. And that's how you would write that in set notation. You would use the word or because the x get values can be here or here. In interval notation, you would write this as follows. Starting at negative infinity and going to -2, and a square bracket because that value is included. And we use a big U for the symbol for OR, means the union, and 2 to infinity. So that would be the interval notation for that domain. So try 6, A, B, and C, and try number 10 now.